So, can you tell me the primary reason why we build software, in your opinion? Very simple questions, just to put things into perspective, so that we don't lose perspective. We always, understand what we are doing and why we are doing it. Okay, so Saurabh has answered to solve problems. Okay. So to solve problems. Okay. So that's kind of a broad answer, but it's okay, to solve problems. What else? Okay. What else? Why do we write software? Why do we build software? And why are there so many software companies in the world? What are they doing exactly? For doing smart work, to solve problems and save time. Okay, to solve problems. Okay, let me rephrase it now. To ease your life, to ease some work problems, to ease your life. Okay, so let me rephrase it. Why do we solve problems? To make life easy. Okay, Kavita has said to make life easy, to ease your life, to ease some work. Yeah, that's a beautiful answer actually. Okay, can I have a few more answers? You have answered, we build software to solve problems. So why do we solve problems? Very basic question. Why do we solve problems? To earn money. Okay, to earn money. Okay. Save time and easy work. Well, to earn money, I won't put it as a very specific answer to this question, because we do everything to earn money basically, whatever profession we have, right? So that's to earn money, that's okay. But why exactly do we build software? Right, we could earn money in some other ways also. Okay, so save time and make our life easy. I think the best answer here has been to make our life easy. So basically we do it to automate. Okay, make our lives easy. And by our, I means the whole humanity, not just my own life. Okay, because if it's just my own life, I'll build something for my own home, right? But we want to make life easy for everyone on the planet, so we want to automate whatever we are doing manually. We want to automate that process, so that we save time, we save effort, and we save a lot of resources, and humans are freed up to do more interesting and creative work. Okay, so this sometimes this thing that we want to automate, we want to make life easy for ourselves, and we want to make life easy for everyone else, sometimes becomes conflicting in some ways. So that is why it's very important for us to keep things in perspective. So even though we see that we are automating a lot of things, our environments are more and more comfortable and automated, but still there is a lot of kind of stress and all those sorts of things. We are not able to manage our lives properly. So that is kind of a conflict. So we have to keep things in perspective, moving on into the advanced technologies during this course, and that will be very important, because you will realize that the whole aim or the whole purpose of why we are building software is to make our lives easy. And if it's not becoming easy, that means we are doing something wrong basically. So even when we are building software, even when we are automating stuff, it should feel very it should feel easy, it should feel simple, it should not feel like a heavy, tedious work. Okay, so that is something that you have to keep in perspective. When you're learning a new technology, for example Java, and then you later on try to understand why microservices, or why this or why that, so never lose perspective that we are trying to make things simpler, right? We are trying to make things simpler. We should never feel that we are complicating stuff. It's everything whatever we are doing, the software industry, the way it's evolving, it's actually making things simpler. I don't know if you would believe me, but writing code or writing software was way more difficult 20 years ago, right? Or even 30 years ago, or even 15 years ago. Today, even if you're not an engineer, even if you're in school, for example, and if you get the right guidance, if somebody tells you how to use some tools and gives an introduction to you to the right technologies, even a 10th class student or 11th class student, if he has the right, mindset and, everything in place, he can actually build enterprise grade software today with free and open source technologies, which are freely available from the internet. You can download it and you can work it. So the software industry is going into a direction where everything is becoming more and more easier, right? So what is the challenge? So here comes the question, what is the challenge? Okay, I am still waiting for one more reason, so I'll just leave it there. Okay, so can you tell me the challenges of building software? Okay, we got the understanding why do we build software to solve problems, automate. So basically, see, we are automating everything. We are trying to automate everything that's possible. And when you put AI and ML into picture, you realize that tomorrow you want your machines to automate themselves. So you don't even want to build software tomorrow. You want your machines to build software for themselves. So that is the level of offloading or outsourcing we are doing towards the machines, not even the humans. So as humans, as software engineers in 2022 and moving forward, you have to have that mindset. Do not try to do stuff the hard way. Always look for easier ways, simpler ways to do stuff. If you try to find hard ways to do stuff, maybe to show to yourself or prove to yourself that you can handle complex stuff, and whatever may be the reason, right? Or to prove to someone that you know so much, what you will be actually going in the opposite direction of where you're supposed to go, right? You're supposed to make life simpler for yourself as a software developer, and also life simpler for the users of your software, right? So that should always be your main direction in which you are heading. Always go for things that makes everything simpler. Okay, so Tushar has a comment. One of the members, Pranali, could not join. So that's okay, because there will be a recording of this session. So she can attend that, and that's not a problem actually. We can accommodate her when she is available. Okay, and if there is a problem with, let's say, logging in or something, you can connect with the Edureka team. Whoever is the team leader here in the batch, they can connect with the Edureka team, because there is not a lot that I can do if some of you are facing technical issues trying to join the session, or maybe the LMS, right? So you can talk to the Edureka team and they'll sort it out. Okay, so you got an idea of why we build software. Now let's talk about what are the challenges. Can you tell me some of the challenges? Some of you are have 5 years plus of development experience. So can you tell me the challenges that you have faced in your life while building software? This actually is more interesting, and once you answer this question, you'll understand why exactly do we go for frameworks. And why exactly do we go for stuff like Dockers and containers and Kubernetes and cloud and so on and so forth? Okay, so Pratibha has answered, I think, the earlier questions to remove manual redundant work. That was why do we build software. So now I'm looking for an answer. What are the challenges that you have faced in your life while building software? Okay, Saurabh has answered, requirements not groomed enough. So basically, you started building software without actually first defining what you are building, right? Or in which direction you are actually going. It's a very good thing, right? So let's call it project structure not well defined in the beginning, and you'll realize how software development paradigms these days are addressing these challenges. You'll be surprised, you'll be surprised at how these challenges are being dealt with, and then you'll understand why we are using all these technologies. Okay, first, how to structure it and deploy it. Okay, So the challenges have been how to structure it and deploy it, right? So that's the challenge. So I'll put it in the same category. Project structure not well defined in the beginning. Task clarity. Okay, so task clarity, I think not getting task clarity, that has to be a problem from the manager's end. So he's not able to, for some reason, clear the task or the expectations from you. So I will not put it as a developmental challenge. It's more of a the project level challenge. Okay, lack of technology knowledge. Lack of technology knowledge I will not put as a challenge, because that you can overcome. Because today, if you're not good at Java, after the end of this session you'll be better, and then you spend a month or two more, then you'll be good enough. So that's not really a challenge, because if you call that a challenge, then everything is a challenge. So you can develop your knowledge of the technology. Which technology to use? Yes. So let's call it continuously changing tech stack in the world. Let's call it in the world. Okay, so which technology to use? Pratibha said which technology to use to solve our problem. So that is a very good, that's a challenge actually. What technology should we use? Whether it will be still relevant in the future, whether we have to spend a lot of time and effort to learn it initially, whether it will be able to provide proper solutions to our problem, right? So yes, definitely choosing the proper stack. We call it a stack because these days, you don't have a single technology or a single tool. You have a multitude. So let's say tens of tools, 2 or 3 technologies. So for example, you will be using both Java and JavaScript. You'll be using both Tomcat server and Node.js server. So we'll talk about that later. So that's the challenge that software developers face. What technology to use? Okay, there says how to connect with real life problems. So yes, so that is also a challenge. That's also a challenge. Technology and domain intersection. Right, where does the domain intersect with technology? So that's the challenge, right? So whether what you are building will actually fit into the domain. So domain could be anything, right? So domain could be banking, domain could be payment solutions, domain could be international trade, domain could be defense, right? A domain could be let's say enterprise resource planning. So domain is anything that is the problem in the real world that you're trying to solve through software. Another thing here that you need to understand is that software in itself, is an enabler in itself. It's an enabler, but it's not really the real thing that brings in money for an organization, unless it's a pure technology business. So for example, Oracle, right? So it's a pure technology business. Right, so they sell technology solutions to other companies. So for them, yes, the main earner for them is technology. But for the majority of the businesses in the world, technology is an enabler, right? So they invest into technology to the extent that it improves their profitability or efficiency, or in some way benefits the entire organization. So for example, let's say the Indian government, right, or any other government, or say the government of Estonia or Finland. For example, these countries, the government of Estonia, Finland, Nordic countries, Sweden, Denmark, these countries have invested heavily into IT or software when it comes to the governance, right? Almost all the departments, government departments in these countries are interconnected, right? And they might be using varied solutions or varied platforms. Like one department may have used Java, the other one might have used C++ or something else, but they have found ways to connect all of that together. So you have to understand that technology is an enabler for businesses. It's not in itself the main thing. So for example, if you take the example of Zero Dha, you must have heard about Zero Dha, right? Nitin Kamath, and there is the other guy who's the CTO. I'm forgetting his name. Kant is his surname, right? So Nitin Kant, I think, or something else, Kamal. So basically, these people have a stockbroking agency and they have built their own technology platform, which is Kite for stockbroking, from the scratch, and they're maintaining it, right? So even when they didn't have this proper, technology platform called Kite, they still were doing business, right? But when they automated all of these things and they opened it up to the public, they grew 1,000-folds, right? So you have to be very clear in this, that technology is an enabler for an organization, unless it's a pure technology business like Google, right, or Oracle or Microsoft, right? Unless and until you are a pure tech company which is selling technology solutions, technology is only an enabler. So you have to be very, very sensitive to the domain requirements of the organization. So I'm not very clear about what Blanco does. From what I understood, your company is kind of a technology solutions provider. So for you, yes, the domain and the technology coincide to a great degree. But for a lot of organizations out there, for example, Swiggy or Zomato, technology is an enabler. Right? It's not the main thing. It's not the main money earner, right? So you have to keep that in perspective. So tech and domain intersection, that's a challenge, right? Sooner or later in your careers, as you move forward, you will acquire some domain expertise, right? So that's the challenge, how to translate domain issues into and we'll see how we solve that with Java. Okay, missed feature planning, unrealistic or mismanaged timelines. Okay, so yes, improper project management. Okay, so these are some of the challenges that we face, and let's mark this as why software. Okay. So sometimes in the bid to make our life easy with software, we stumble into the pitfalls that are the challenges we have listed below. So we have to make sure that we, in order to make our life simpler, we don't inadvertently make it even more difficult. And that's why we are trying to learn a technology which enables us, to do all those things. Even though, 10 years ago or 15 or 20 years ago, building software using Java was much more difficult, and today is much more easier, and that's what we are here to learn. Okay, so which brings us to another important question. Okay, so when we are solving these problems, as you said, using software, right? So when we are automating, when we are solving problems, and let's call it /automating. Can you tell me what is the stuff that we are dealing with primarily? From the domain, of course. What does the domain give us? Technology is, of course, understood. But when we are solving a domain problem, let's say you're Swiggy, Zomato, or let's say Meesho or Amazon, what does the domain give you that you're dealing with primarily? Basic formulas, if they're about that domain. Okay, what else does the domain give you? Just think, what else is in demand, such a huge demand for the past 7-8 years in the software industry? What skills are paying the max, the most? What is everybody investing in? What are all these big companies like Amazon and Google, and Microsoft? Yes. So Kavita has answered the question. It all begins and ends with data. Data is everything, right? So why we are having this, course here, why we are having all this discussion here, why we are spending all our time and money, and why your company has hired you, why so much the huge software industry exists, it's only because of data. Right? So never lose that perspective. Code will change. For example, your organization or any organization, the code will change. The technology will change. Maybe today the application is hosted in your own data center. Tomorrow it will be hosted in AWS cloud. Day after tomorrow it will be hosted, some part of it maybe Google Cloud, or maybe 10 years down the line it changes and everything changes, and how code is deployed and how code is presented to the world changes. But the one thing that will not change, that has not changed since the inception of this entire industry, let's say even some of the old companies like IBM since the 60s or the 70s, the data that they have generated since then is sacred, right? It has existed. Maybe its form has changed, the way they are saving and storing that data, maybe it has changed. Maybe the way they are processing that data has changed, right? But the data has remained. So for example, if I'm an organization, I start from a very beginning or very basic. I have 2 users, then I have 10 users, then I have 15. And for example, Zerodha. So they had, let's say, 2,000 loyal customers that they were serving manually out of their office in Mumbai. And then later on, when they automated the entire stuff and they put everything online and they opened up the platform, those initial 2,000 customers remained in their database. Now today they might have 200,000 users, but those 2,000 users and their data and everything still exists to date, right? And externally maybe things are changing, but that data is copied and backed up and moved from one data center to another, but that is kept as the sacred thing why organizations exist. So never lose that perspective. Okay, so now I'm going to mention a few words so that you understand what we will be dealing with in our discussions. Okay, so can you tell me some of the ways in which we store data? I told you data is sacred for all the organizations. So how do organizations store this data? This is just to get an idea of your understanding of the entire thing. Monali says AWS Cloud. Okay, Monali. So AWS Cloud basically is something else. It's not what I'm talking about here. Virtual space. Private cloud storage. So, okay, all these things are okay, but what's the basic way in which data is stored? So, Saurabh has answered databases on cloud and data centers, different database, yes. So, the answer is database. Okay, so can you tell me what is the simplest form of a database? And then I'll ask, what are maybe the different kinds? Yes, so Tushar has answered the simplest database that you could have is your file system, right? So for example, you're using Microsoft Windows, so just when you open your computer Explorer and you see C drive, D, E, and you open a directory and there's a lot of data there, a lot of files, that's basically a database in some way, right? It's a directory structure, it's a tree structure, but it's also kind of a database. It's storing all your data. And you can use that file system to act as a simple database, which we're going to see in the next few sessions. We'll use simple files, .csv files, to store a lot of data that our application will generate. So the simplest database is a file system, and we'll see that in action. Can you tell me the next most common way data is stored, has been stored for let's say 30 years, 40 years in the software industry? What's the next best level? Okay, so Tushar says this question was asked by me in my first interview as a fresher. Well, as I said, right, so the basics remain the same. It's only things are becoming more and more simpler. Okay, so what's next? There are a lot of problems, a lot of challenges if you use the file system as the database solution. Database means to store data. If you use the file system, .csv files or .txt files or whatever, if you use those, there are a lot of problems. I'll not discuss the problems right now, but please understand, if you're a large organization, there are a lot of problems dealing with. It's simple to use, but it's very difficult to maintain, right? So if you lose your data, if your data gets corrupted, it gets stolen, then what's the use, right? the most sacred thing in your organization, and if you get it corrupted or lost, then what's the point of simplicity? Okay, so somebody says magnetic tape. Well, I'm not going to the hardware part of it, right? I'm not going into the hardware part of it. I'm just remaining in the software realm. So in the how you manage that database or data storage, that's what I'm asking. So what's the next step? Where do you go from simple file system? What's the next step that the industry took to store data? Okay. Yes, so Tushar has answered. The next step, what you call an RDBMS, which is Relational Database Management System, right? It is just like a file system, but that said, it has added functionality, right? So it gives you a dedicated space on the hard disk, which you cannot access if you do not have the correct permissions. And even if you have the correct permissions, you cannot by mistake make some changes to the data, right? And so many other facilities. So the problems that exist with the simple file system are removed when you move to a RDBMS, but it is still close in structure to a file system, because in a file basically you have to define a schema, or let's say if you have used Microsoft Excel, so an Excel sheet has a lot of rows and columns. So if you want to put some data there, basically you'll have some headers, right? And under those headers you will put all the data. So those headers basically you have to define. So you have to take a pen and paper and you have to think, okay, how my data is going to be organized. We'll talk about it later. But from the file system, the next obvious step is RDBMS. Can you give me some examples? Tushar has already answered. I'm looking for answers from a few other people, because we will be using an RDBMS while we are building our application. So Oracle database, MySQL. Okay, can you list some others? One most common other, SSMS, Postgres. Yes, so basically Oracle, MySQL, Postgres are the one of the most popular out there, but there are so many others. There are so many. Trust me, there are so many others, right? And how exactly do you find out what are the, let's say I give you a problem, list at least 20 RDBMS out there in the world. How will you find that out? MongoDB is not an RDBMS. I'll come to MongoDB just now, Hemant. So I'll put MongoDB into perspective as well. So let me tell you let me give you a problem. Just find 20 RDBMS just like Oracle, MySQL and Postgres out there, right? So these are things that you have heard, but there are some of the less popular tools out there which may be better than these, but people don't know about it. So let me introduce this website to you, which is StackShare, right? So just go to stackshare.io, and here you will find a lot of in fact, whatever is going on in the industry, you will find something here. So let us search RDBMS and let's see what comes up. Okay. So let's just take a look at, so I am telling, as I am having this discussion with you right now so that you can understand that you need to build a very kind of broad perspective towards the software industry, right? Of course you need to be good in some technologies, but you also need to be aware of what's going on out there. Every day, every month, every year, there is something new coming out, right? So you don't need to learn all of that, but you need to be aware of the major changes in the way the software is built. I will revisit this point again and again in the future, where I'll tell you, okay, what were the major points in the history of software development where how we build software changed, right? And there might be ideas, okay, we can do this, because right now there are ideas about of paradigms or of ways where you don't even need to write code, right? Just like the Lego blocks that kids use to put things together, and then they make houses out of it, or maybe transformers, or action heroes, or whatever, castles, forts, using those Lego blocks. So there are talks about tools where it will allow you to bring all these blocks together using a computer, let's say using a GUI, where you can just plug things together and it will become proper software. So in future, that is a reality in a way. That will happen. There are some tools out there, but you need to understand how the software industry has evolved. It's very important for you, so that you don't miss something big that's coming in the future. Okay, yes. So basically a lot of changes are happening out there and you need to be aware of that, and that's why you will understand why exactly do you need to learn Java, right? Because there are so many technologies out there. What's so great about Java? Okay, so let's take a look at some of the database solutions that we have. H2 database, we will use this database. You might not have heard about this database in the past, but we are going to use it. It's a very low memory, like lightweight database, which is used usually for testing purposes, or maybe if you are using as a cache. Let's say cache is something which is used to store data for some amount of time, but not for a very long time. Okay, so H2. Then you have Oracle, of course, right? Postgres, and then just check out these names. Like there are some things which are related to databases, but not databases in themselves. But just get an idea of the amount of tools and solutions out there when you talk about databases, right? So that's the entire point of this discussion. You need to be aware why you are learning a particular technology and what are the other options available, what's good about something, what's bad about something. Okay, which brings us to the next thing, which is what next after RDBMS and why, which will bring us to our initial discussion of the challenges and why software and everything. Okay, somebody answered already. Hemant answered that, but now I'm going to put that into perspective. Serverless cloud. Well, no, see, serverless cloud, all these things, they're not related directly to data, of how data is structured. Serverless and cloud is mostly deals with where exactly do you have your machines. For example, do you have them in your own building, or do you have them across the world? So for example, Netflix, you watch Netflix, right? So can you tell me, Netflix is available in all the countries across the world, almost all the countries which are medium and high income countries. So can you tell me where are the Netflix servers located in India? Because of course their data is of course not coming from the US, right? So can you tell me the name of the cities where Netflix is serving you content in India? And where they have their data centers, where are all these movies being stored that you stream a few times a week? This will give you an idea, because a lot of you are saying cloud and serverless, so that's to put things into perspective. Take a shot, take a guess. It doesn't matter if you get it wrong, because asking questions is important. Asking the right questions leads you into the right direction. Okay, but Tushar says, but as per AWS implementation should have deployed in specific regions. Okay, so, and can anybody else answer? Any guesses? How many data centers that Netflix have in India, and maybe in which cities? Can you take a guess? How many data centers that Netflix have in India? Let's just ask that question. Like Netflix owns that data center, that building, that server and everything, has its own team to manage it. You can take a guess. 1, 2, 3, 10. I'm not getting any answers. Okay, so basically Netflix. Okay, so there says 2. Tushar says I don't think they have their own data center. There says 2. Well, basically Netflix does not have any data centers of their own anywhere in the world. So Kavita says 0, Hemant says AWS cloud. Yes, so that is where this cloud thing comes into picture. Even an organization or a company as big as Netflix does not own any data centers of its own across the world, wherever it's present, right? So South America, India, Europe, US, it doesn't have any data centers. It uses AWS. So AWS has its data centers across the world that Netflix uses. Now that's a choice that Netflix makes, right? It's not necessary for Netflix to use AWS and not have its data center, but it's a choice that Netflix makes, because tomorrow if some market is not profitable, for example in India, Netflix is not doing so great, right? It's not making a lot of profit in India, and it has done a reduction in its subscription prices as well. So in India it's not doing so great a business. So maybe let's say 2 years down the line Netflix decides to quit India. So all it has to do is just stop its servers that are running in the Indian region, right? So Mumbai or Singapore, and it's over. It doesn't have to sell its machines or sell its buildings or whatever data centers is there. So that's what cloud means. Okay, that's what cloud means. I'll come to another reason why we go for cloud, or why any company would want to go for cloud. In another way, for example, let's talk about Zerodha. Right, it's a way smaller company than Netflix, but it does not use AWS. It has its own servers, right, in Mumbai. Right, it has its own servers where it hosts all its data and which it connects to the various stock exchanges. So that's a very critical decision where an organization decides whether it wants to have everything within its own private data center or whether it wants to go for cloud. So on one extreme you have, let's say Netflix, which is 100% AWS, and let's say Zerodha on the other extreme, which is 100% its own data center. Now they might have taken that decision because their data is critical. They are storing a lot of credit cards and financial data and stuff like that. So they might not feel very comfortable going for AWS, let's say, or giving it to someone else basically. Okay. Also mentioning Zerodha, I told you that you use a database, Oracle, MySQL, Postgres, but let me tell you, this is from the CTO of Zerodha himself, who says that even today a lot of stock exchanges at the end of the day, when the day trading closes at 3:30, right, and after 4 when it is the markets close, these stock exchanges still send a lot of data in plain CSV files. They don't use any database management system. They store that data in CSV files because that's been going on since the 80s, since the 90s, when the entire stock exchanges were computerized. So they didn't use any database systems then. So that thing has been going on since then, right? So at the end of the day, they get the entire the log or the dump of whatever trading happened today. They get a lot of that in CSV files, right? So they ensure that it doesn't get corrupted, because that's a serious problem with file systems. So this is just to tell you the challenges that exist in the industry today. The older systems still work with the older ways, and the new systems work with the new ways. So sometimes you have to find ways to bring them together. Okay, so now the next thing that the discussion brings us to is what is the next step after an RDBMS, and why do we need to go there? And some of you already answered that question here, where this thing you said, project structure is not well defined in the beginning. So the point here is that the client comes to you, right? Or maybe you are building something for your own organization, and you don't know what will be the final shape of the product that you are building. Right. When you start, you just have an idea. Okay, I am Zerodha. I do stock trading. People come to me and put open account balance with me, demat account, and then they tell me to buy that share, sell that share, and then we do that. So now we want to automate it, and we want to open a online, let's say, website or a web app or a phone app, Android app, where people can do that automatically instead of calling me and calling my team to put, a seller share or a buyer share. They can just do it online. So that's me. But I don't know, like when I start building and when users start using, what will be the problems, or what will the UI look like? What will the data look like? Where will I store my data? What will be the column headings of all the tables? For example, I told you if you're using Oracle or MySQL or Postgres, just like in Excel sheets, you have to define the table headers. So let's say you're Zerodha and today you're sitting there and you don't know, like I know only like 3 headers. Customer name, customer wallet balance, and something else maybe. But I don't know the 25 other headers that are going to come in the future. Tushar has said MVP, which is minimal viable product. Yes. So everything starts from the MVP, or the minimum viable product. You build what you know today. But you can't build what you know what you do not know today, right? You don't know like what's going to happen with your organization and your product 2 or 3 years down the line. So how can you build it? So that was a huge problem. That has been a huge problem with when you go for software technology that demands that you have to know everything before you start building your software. Right, so that's a huge challenge, and that's why a lot of software projects fail, because by the time they end up building, it doesn't solve any problem at all. It's just an exercise in itself. People want their salaries. People just want, okay, I did this, I wrote some code, just give me my salary. I don't care what happens. So that has been the challenge with the software industry. Like, a huge percentage of software projects that organizations build don't end up anywhere. Right, they're not usable by the end customer, because you don't know how it's going to look, but the way you are building it is demanding today itself. You have to tell or decide or make a huge sheet or something, tell how the end product is going to look like. So to solve that problem, some major shifts have happened in the software industry, in the way software is built, and then appropriately the tools that are used. Okay, so one thing that is used for that purpose, or has taken birth out of that challenge, is called NoSQL. Okay, and as somebody already said MongoDB, let me find out. Okay, Hemant said MongoDB, right? So MongoDB is one example of a NoSQL database. So what is a NoSQL database? First of all, what is an SQL database? All these are DBMS. You can also call them SQL databases. Okay, so what is an SQL database? Can some of you explain to me what is an SQL database? You will find at the end of this discussion, introductory discussion that we are having today, you will get that the software industry actually is not that complex or really perplexing. It just seems that way. It's actually, it can be summed up into a few things. Okay, so what is SQL? Tushar says data stored like JSON format. Okay, I suppose that's the answer for NoSQL. But Kavita says structural format, sequential data. Okay, so what's the full form of SQL? If anybody knows, doesn't matter. So Saurabh says structured query language. Okay, so let me just write it down here. Structured query. Okay, so structured query language. Now forget about query and language. Just take a look at this word structure. Okay, just take a look at this word structure, and then take a look at this first challenge that we posted. Structure not well defined. And that has been the primary challenge. You are developers, right? And you have faced this problem. Project structure not well defined. So if the structure is not defined, then how will you use a structured query language? If there is no structure, how will you use a structured query language? So you have to go for a no structure query language. No structure. Because I don't know. I don't know what's going to happen in 2 years or 3 years. I don't have a structure today. So I have to go for a no structure query language. What that basically means is that you don't now have to think in terms of an Excel sheet. Okay, so now you don't have to think in terms of an Excel sheet where you have to write down the table headers. For example, serial number, customer name, customer phone number, customer email, customer address, customer wallet balance. You don't have to do that exercise, right? Whatever data comes in whichever form, you just save it. You don't worry about what are the column names and the headers and whatever. Just save it, because you don't know like what form the data will come in. Okay, so to the extent where you know the data structure, you use ARDBMS, and to the extent where you do not know the structure, you go for a NoSQL. So usually these days everybody goes for a hybrid solution, because of course RDBMS has some advantages. In some cases it is faster than a NoSQL. When you have a structure, there's no sense going for MongoDB. When you have a structure, go for Postgres or MySQL. When you have a structure, already know the structure, right? But when there's no structure, you still have to work, right? You cannot just sit there and wait for the structure or build something wrong. Both the options are incorrect, right? So when you don't have a structure, you go for a no structure query language or a MongoDB solution. And to the extent where you have the structure, you use a structure query language. Simple, right? So most of these days, you will always find hybrid solutions to this problem. Okay, so Hemant says instead of storing data in relational tables, store in file format. Well, see, file format is not used, as I said, because there are a lot of problems with simple file format. The reason is, security issues, accession issues. Anybody can change it. You can change it by mistake, and once it is corrupted, the machine cannot read it. Right, so that's called data integrity, data security. All these issues are not so well addressed using a file system. So file system is out of the question. File system these days is used for very basic, very simple configuration properties. We'll talk about configuration properties and what that is later on. But for now, you can imagine that it is, file system is used only for 0.0000001% maybe of the total data that's being generated. Of course, not the domain data. So file system will never be used for the domain data. It will be used for for the code data, the data that is required to configure your code, right? Okay, so RDBMS. So what have you understood here about data and database? Okay, so if I give you a problem today to build, we will build we will solve a problem. We'll build an app during the duration of this course. So can you answer me now, do we need to go for 100% RDBMS, or do we need to go for 100% NoSQL? Because some people might say, okay, NoSQL is the next step, so why do we want to go back? So what's your answer? Do we need to go for 2 or 3? 2 is RDBMS or SQL, and 3 is NoSQL. So what do we need to do? We have to take a very strict approach of one or the other? Pratibha says 2. Monali says 2. So those who are saying 2, everybody is saying 2. So that means we should not go for NoSQL. Is that the answer? So if I give you a problem, you will automatically go for MySQL, Postgres. You should not even think about MongoDB. Is that the question? Is that the answer? Pratibha, Monali, Rahul, there says 2. Pratibha says no. Okay, so Pratibha, some other people can also answer, but Pratibha, so why would we go for MongoDB if we have all these Oracle, MySQL, Postgres? Why would we go for MongoDB? Why should we go for MongoDB? And will MongoDB our permanent solution? And Tushar says, as per current work in Blanco, we should go for 3. So, okay, so why should you go for 3? What is the exact need, Tushar, from our discussion? You said, as per current work in Blanco, we should go for 3. So why is that? What is that kind of work? I'm not asking the exact problem, but why from our discussion, what you understood, Why do we go for NoSQL? Okay, so there it says because we can handle worst case scenario with 3. Yes, so there you have answered that question to a great degree. So as I said once again, there is no okay, Tushar says there is no guarantee of data being processed. Okay, so basically see, if the problem is such that the entire structure of the data, the way it is going to be stored. For example, let's say a university, right? A university, an engineering college, which stores its students' data, examination dates, examination results, and so on and so forth. So an organization like that is automating its entire, database of everything that it generates, the data, student marks, student, projects, and everything. So the structure is very well defined. And in that case, you don't need to go for NoSQL. You don't need to go for MongoDB. Your job will be very well done by Oracle or MySQL or Postgres, right? But let's say you are building an application where let's think it this way. You're building an application where today you are starting from a point. Okay, I throw this question to you because I can think of something. Let's see if you can think of something where you're building an application, but you cannot imagine right now how the data will look like. For example, in a university, student name, student ID, branch, subjects, marks. Just give me an example of a problem that you go out there to solve, but you don't really know how the data structure will look like. Can you give me an example of such an application or such a domain problem? You can take a few seconds and think about it to tell me some domain problem. You might have to think like an entrepreneur. Let's say if you're going to build a startup tomorrow, then can you think of some domain problem where you cannot imagine the structure of the data? Music, yes, that's a good answer. Music, yes. Maybe let's say you want to build a collaborative app. Right, where different people can log in, and medical diagnostics, yes. So different people can log in and they can collaborate to build a song. So you have a vocalist, you have a guitarist, you have a drummer, and they're all located in different parts of the world, and they are working on one track, right? So one guy is composing the entire thing, one is singing, one is playing guitar. So yes, so building an app like that, you don't know what the data structure will look like, right? So you have to go for a no structure. Medical diagnostic, yes, that's a very good example, because if you have paid attention, there is a company by the name of HCL Avitas, which has been trying to automate, trying to capture Indian market by automating this entire connectivity between hospitals and clients. So let's say you got yourself diagnosed in Delhi and then you move to Bangalore for job purposes, and then you go to a hospital there and they'll check your, let's say, PAN or Aadhaar or maybe phone number, and they'll get your entire diagnosis right in front of them. Or maybe tomorrow if you go anywhere in the world, all your diagnostic reports, you don't have to carry them along. So, these are the kind of applications where you don't know right now what would be the structure of the data. So if you are facing, an app like that, then some part of that can be, delegated to MongoDB or NoSQL data. Okay, so I hope you have got a clear understanding of why we build software. It's basically because of data. And then how do we store that data? Use a database. What are the different kinds of databases? You have a file system, which is still used in the stock exchanges of India and other old government organizations across the world. The next step is an RDBMS or a structured, query language supporting kind of application where the structure of the entire data. Okay, so that happened when you already had old legacy kind of organizations migrating themselves from manual, keeping manual registries of stuff into automating their So they knew everything. What is the structure? And now we are in a need of NoSQL and MongoDB because we are building a lot of startups. Right, for example, as Tushar and there says, music and medicine are two fields where we don't know, like these industries have never been organized since their inception, right? So basically when you enter this, you don't know the structure, so you have to go for let's say MongoDB. At this point, there is another interesting thing that we can discuss from the challenges. So as you said, project structure not well defined, continuously changing stack, improper project management, right? So let's go to the next slide and let's see some of the terms that you might be hearing here and there in your industry, but maybe you don't have an idea of what that means. So let's see. Okay. So when software was built, let's say in the 90s, in the early 90s, when the internet was already there. I won't go to the 70s and 80s because that was pretty young at that time. People were still experimenting. But in the 90s, when internet was a real thing already. So when the softwares were built back then, what you had was a data center. Every application, every organization had its own private data center and hosting, okay, upon which they used to host their static websites. Okay, so that's Web 1.0. That's what you call, right? Web 1.0. So 90s. Let me just write it here as well. Okay, so that's your Web 1.0. I'll relate this to how some of the terms that you might be hearing. Okay, so can you tell me what's Web 2.0 then? If Web 1.0 was static websites means you just go to a website like Wikipedia and you just read what's written there. That's all. You can just read and you can do nothing else. Or maybe enter some data like, okay, your name and address and register or sign up or something. But some pretty basic stuff. The page is very static. You cannot interact with it. That was the whole of 90s, Web 1.0. So Web 2.0, let's call it the 2000s, right? So that was still, private data center, private hosting. But then you had dynamic websites. So once we say dynamic websites, it means that right now in front of you, I'm using this Google Jamboard. So it's open in a web browser. So it's basically a website, but now because it's Web 2.0 and 3.0, so it's not a website anymore, it's a web app. So I can interact with it. There are so many buttons and there's so much rich functionality. So that was your Web 2.0 2000s. Still data centers. So if you want to host a website, you either contact a hosting provider or a data center, or you have your own huge data center. So those were the only two options that you had. Okay, so before moving forward, can you tell me what was the main language or technology that allowed static websites to become dynamic? We will correlate it later, although it's not part of our course, but it's still good to know the technology that made Web 2.0 possible. And why it's important is because if you're learning Java microservices, you have to know what are the alternatives, for building apps. So the static websites were made dynamic using JavaScript. HTML was already there, right? HTML was already there. So HTML was the beginning, but then, the development in JavaScript really, and the creative ways in which it was used really changed the way people interact with web apps or websites. PHP, not really, because PHP is still more of a server-side programming language. It's not a browser programming language. So JavaScript is the answer. Always remember that. The JavaScript is the language of the World Wide Web. It's not Java, it's not PHP, it's not anything else. It's JavaScript. And then I'll connect it later to some major changes that are happening in the industry now. Okay, so what is Web 3.0 then? That is what you have after 2010, let's say. Web 3.0. Can you specify what happened after 2010? Web apps, React.js, AngularJS. Well, basically you had two things that changed in the past 10 years, right? One was cloud and the second was web apps. So you don't have, Web 1.0 was static websites, Web 2.0 was dynamic websites, but it was still websites. So it was like a static page which you can interact with. But now you have complete web apps. So for example, you don't have to download Microsoft Word on your system. You can use Google Docs, for example, right? So it's an entire application that's running inside a browser. It's not a dynamic website. It's an entire app. You don't have to install it anymore. And the second thing that happened was the emergence of cloud. So cloud is, you don't need to own your own data center. You don't need to have your own hosting, like your own basically stuff managed by yourself, your system administrators. So there used to be a job that of the system administrator. So I'll put it here. And there were Cisco certified system administrators and stuff like that. This was hugely in demand, right? So this course used to be very popular. Cisco certified system administrator, and then there were sort of a lot of things here. But this job or this job category has diminished quite a lot in the past 10 years, let's say, because more and more companies and new startups and everything are not going for building their own data centers or buying their own servers. They are going for cloud. Right, they're going for cloud. So this job now is not so much in demand because there's not so much demand. Huge companies, of course, still have the companies that manage their own data centers. They still have system administrators. But earlier it was a necessity for everyone. Now it's not. Okay, so Web 3.0 is cloud and web apps. Okay, so can you tell me how this cloud thing happened, where basically you can start from a very small point, from paying almost 150 rupees per month and have your entire website, web app, not even site. I mean, something like Google Docs being hosted for the world to use for maybe as little as 1,000, 1,500, let's say. If it's a web app, of course, it will be a bit more expensive. So can you tell me the organization or the company which is responsible for the emergence of this concept of cloud, which means you don't you use data centers of other organizations on a pay per use basis, so you pay only for as much as you use, and then you can scale your usage as you go ahead. Tushar says, is it IBM? Amol has already answered. I'm looking for a few more answers. Can you tell the company which is responsible for the emergence of this concept of cloud? Pratibha says Google. Akshay says Salesforce. I've already received one answer, correct answer. I'll not mention that right now, but can you, because you have been hearing about this Google Cloud, Microsoft Azure, Google Cloud and all these things. So what is the company, which is the company which actually thought about it? Okay, so why don't we offer our resources to other people for money, and in a very small way? So we package it in a small way, and then as their need increases, they pay more for whatever the increased need is. Okay, so I've got a lot of answers, but you'll be surprised that the company that's responsible. Okay, a lot of companies might be thinking about it, right? Might be thinking about it, because it's not that the idea that you're getting, the great idea that you're getting in your head, nobody else is getting it. It's not like that, right? All across the world, when we reach a certain level of technological advancement, a lot of people start thinking of the next step or the next what. Right, so maybe a lot of organizations were thinking about it, maybe some of them were using it on their own, but the one organization or company that moved fast and brought it out in a commercial way was Amazon. Right, so as all of you know, Jeff Bezos, Amazon started as a bookstore, online bookstore, right, selling books, but then it started selling other items as well across the US in the early 2000s. But then at some point they realized that they have bought a lot of machines, a lot of compute power, for example, a lot of servers and a lot of memory and everything, like a lot of powerful computers that they bought to manage their needs at the time of huge demand. For example, just before Christmas or Black Friday, I don't know what goes on in the US, all those things, right? So basically for those periods where they have huge demands, surge, so they bought a lot of extra hardware to manage that surge in the demand, right? But then later they realized that's lying dormant just for 15 or 20 days of usage in a year. That basic hardware is just lying around. So what Jeff Bezos and other people thought about it is like, how can we give access to other people to this hardware and make money out of it? So maybe other companies were thinking about it, but they were the ones who built an API around it. API is like when you give an access to other people to your application or your infrastructure. And from that point onwards, it was Web 3.0, as simple as that. So then you had all these kind of things like SaaS and PaaS, right? And then you have this thing. So that all started from Amazon deciding that, okay, we want to pivot from being a online store to be a technology company, right? And that was the birth of Amazon Web Services, right? So when they had a lot of dormant technology hardware and stuff just for 15-20 days in a year when their peak demand surged, other times it was just lying around. So that's it. So that changed the entire industry landscape, and then you have these things, so which once again solves your problem. Going back to this, project structure not well defined in the beginning, continuously changing tech stack in the world. So these two problems were solved by cloud, this concept of cloud. Of course, now you have the Google Cloud, you have Microsoft Azure, and with AWS, these are the three major cloud providers in the world. Of course, there is Oracle Cloud as well, and there are so many other cloud companies more or less out there. So it has become the next step in the software industry. So this was to solve this problem once again. Project structure not defined, continuously changing tech stack. So initially you don't know like how much hardware you're going to use, right, when you're solving this problem. For example, the music app that Tushar is building, or the medical app that let me check who was the person. Okay, Dhar said. So you don't know like initially what is the hardware, the amount of hardware they're going to need. So what you can do is you start with one of the cloud providers. You start with whatever memory or CPU that you want to use, and then you scale up as and when the demand grows. So that solves some major challenges in software development. So coming back to this, because we are dealing with microservices in this course, so now can you tell me what is this SaaS and PaaS and IaaS and XaaS and whatever is written here? Can you tell me what this is? Because it's tightly coupled with this concept of the cloud. Very tightly coupled. Because cloud came, so you had these terms. Okay, services, software as a services. Okay, software as a service is SaaS. What is PaaS? What is PaaS? Okay, IaaS is infrastructure as a service. Okay, so infrastructure as a service, AWS is an example of infrastructure as a service. So AWS gives you access to a lot of technology infrastructure, servers, memory, CPUs as a service. So you pay for whatever you use. You never even touch any hard disk. You never even touch any server racks, but you're still using them. So that's what infrastructure as a service is, right? And AWS has given that to you. So that's IaaS. What is PaaS? Platform as a service. Okay, platform as a service. So platform as a service, as I said, Zero-Da is an excellent example of a platform as a service. So it's not a software. Like you don't log into Zero-Da to make a make a document or PDF or a presentation. You don't do that on Zero-Da. You use it as a platform to trade in stocks. So that's a platform. So that's a platform as a service. And then extending those concepts, now you have the concept of, as Meenakshi has very rightly pointed out, this XaaS is anything as a service, right? So anything in the world that you can imagine can be provided as a service. So for example, Uber, right? Uber is an example of XaaS. Right? It's anything as a service. So today you can book taxis, then you are able to book Uber Eats, you can order food. They'll have helicopters or mobile cars in 10-15 years, drones carrying your stuff. So anything as a service. So basically anything that you want to provide to the world, you provide it as a service, and cloud is behind that. And the reason for that is you don't know initially the structure of the data or the service that you're going to build. So for example, Uber started the taxis, but now it's providing food as well, Uber Eats. So you don't know. So you start from somewhere, you use a cloud, you use the bare minimum allocation of resources, you use MongoDB to store your data, unstructured data, and then you go forward from there. Okay, so now you understand what are all these words being used. Okay. So, which also brings us to one last very important term that you might be hearing a lot these days. Some of you might be intimidated by it, scared, fearing it. What that means, I don't know it. You're afraid to answer it. So can somebody tell me what DevOps is? It will remain within our classroom, don't worry. You can be wrong. Trust me. A lot of people out there have a lot of different definitions for this phrase. So take a shot, then I'll explain it to you what exactly this thing means. And then you'll realize it's nothing new basically. It's just the change in the way we are doing things. So Rahul says development and operations. Well, okay, development and operations. Okay, and what? Development we all understand. Building software. What is operations? What is operations? In DevOps, dev is development. What is operations? Development plus infra, Meenakshi says. Okay, so development plus infrastructure. So what is this operations? Complete package to manage and organize. Development and IT operations. That's what I'm asking. Can somebody answer what is this operations? We all understand development. What is this operations? What is this operations thing? Are you developers or are you these operations guy? What category do you put yourself into? So what is this operations? Take a guess. Don't worry about it. CICD. Well, yes. No, CICD is actually a term that comes after DevOps. So if you can answer DevOps, you can easily answer what is CICD. But what is the operations in DevOps? Development, of course, is understandable. Whatever functionality a software developer provides comes under IT operations and maintenance of software. Okay, so let me take you back to the 90s. Okay, so back in the 90s, there were two kinds of jobs in every technology-based organization. For example, let's say Amazon. When Jeff Bezos started to build Amazon as a bookstore, he had two kinds of technology jobs. One was for development, right? So developers are the ones who built the dynamic websites. So Amazon was built in the late 90s and early 2000s. So we'll put it in the category of Web 2.0. So there were people who were there to build the dynamic websites, how Amazon looks like. I don't know if some of you in the 2000s used did online shopping or something, then eBay came before Amazon to India. Right, I personally remember ordering something on eBay, so that came before Amazon, and it was pretty dynamic kind of, Web 2.0 kind of look and feel. So there were two kinds of job. One was the developers who are building the dynamic websites, and the other guy was the sysadmin. Just listen to this very carefully. Two kinds of jobs. One was the developer of the dynamic website, right? This guy who is building the dynamic website, and the other guy who is the sysadmin. So who is going around in the basement, checking out servers, logging into some system and checking which server is on, how much is the CPU usage, how much is the memory usage. Okay, so this was the guy who was the sysadmin. So the developer developed the website and he went on a vacation for 15 days because he did developed all the features. The website is working, tested, and it's deployed for public use. But this sysadmin guy never got a vacation, because he is responsible for the management of the data center and whether or not the website is up and running. So the developers were the cool guys. They were like the fighter pilots of the Air Force, right? So they get their job, they have to fight a war, let's say once in their entire career, or maybe twice maximum, right? So but they're still cool, because they're the fighter pilots of the Air Force, right? They fly, these fast, planes and jets. But day in and day, so they get their vacations, they get their holidays, they are celebrated, and but these guys, these ground of the ground staff or the air staff in the Air Force, they do their work day in and day out to maintain the hangars, to maintain the fighting planes, to maintain all the other infrastructure that a fighter pilot uses maybe twice or thrice in his life to fight a war. Other times they have their sorties. So just compare that to the software industry. So you have the developer who has developed something really cool, and now he has gone for a 6-month vacation. He'll still get paid for it because he knows how he has built it. You don't want to get him angered. So once he'll come back, he'll add some more features, but he gets a long vacation, right? And he's the cool guy. But there is this system administrator guy who doesn't get any vacation, who's practically living in the basement of the data center. Every day he wakes up and checks if everything is fine. Every night he goes to sleep by checking everything is fine. And God forbid if something happens at 3 o'clock in the night, it's not the developer that answers, it's the sysadmin, right? So what has changed in Web 3.0, right? What has changed is these two roles and these two jobs have become very tightly integrated. Right, so now we don't have these two separate guys. One is the fighter pilot, one is the ground staff. No, the fighter pilot himself is managing the hangar or the plane. He's maintaining it himself. So that is what has changed. Of course, I'm not saying that they are not no more system administrators or there are no more pure developers. Of course, it's there. But the next thing that's happening is you built it, you deploy it, you manage it. Right. So why did that need come in? Can you explain that to me? Why did that happen, that you built it, now you deploy it and you manage it? It's basically your responsibility. How did that happen? Can you imagine? Okay, Saurabh has answered in a way which is actually very close to the point. So Saurabh has answered agility. Okay, so what used to happen was Web 1.0, Web 2.0, a website or a software solution was developed for, let's say, 2 or 3 years. Only development and in-house testing, of course, in-house testing and development. And then at the end of those 3 years, when they were satisfied, okay, this is what we have built, we have tested it in-house, we have tested it with, let's say, 1,000 users, and now we're going to put it outside in the world, and maximum load that it can take is 50,000 users. Right? If it becomes more than that and if it keeps happening, then maybe we'll buy more hardware and we'll put it there. But the development job is pretty much done, and then we can start working on the next version of it. And from here on, the job is for the system admin to keep it up, right? To keep the system up, to keep the app running. Okay, so that was once in a 3-year kind of thing, the deployment, what you say, external deployment. But now this deployment is happening, on an average, let's say once a week. And if you're in a very, very agile kind of organization, it might be happening 3 times a day. Right? So now you don't have the entire app being developed in 3 years and then there's a ribbon cutting ceremony and cakes being cut and champagnes and everything. No, there's nothing like that anymore. Every day, you ship fast, you go to market very fast. You go to the market with your minimum viable product, as we discussed earlier, right? MVP. So you get an idea, okay, this is the basic thing that we offer to our customers, and let's go to the market first before anybody else tries to capture that market, and then gradually we'll keep adding more features here and there. Okay, so if you check, if you're using Licious or Swiggy or some other app like that, you'll see that their interface, or maybe even Big Basket, their interface and their functionality keeps changing every month or so. And new things, and sometimes the UI changes, and backend, of course, they'll be making a changes quite more often. So the thing that has changed is the activity of deploying the code into a production environment from your in-house testing environment used to happen once a year, once in 2 years, once in 3 years, but now it's happening 3 times a day. All right, so basically, the guy who has developed this, maybe he knows what is the requirements of the new version that he has developed, and there might be some software that needs to be installed on the mainframe. So it's not possible anymore to have these 2 separate roles anymore, because how much will the developer explain to the sysadmin? The sysadmin is not used to operating, installing new softwares every day. And besides, there are so many other problems that I won't get into right now, but just find out about what is this thing called dependency hell. Just go out today evening and just find out about this. What's this? Dependency hell. Just go out there and find out about dependency hell. What is it? Okay, so a sysadmin these days, because of the the increased frequency of deployments of software, are facing a lot of problems. So basically, if you are working in an agile organization, these 2 jobs of development and operations, deployment into the production environment, which might happen 3 times a day or once a week or once a month, depends on your organization, but will be done by the developer himself. Right, so that's why it's called DevOps. And so basically it's development and operations going side by side. So you build it, you are managing it, and you are checking it whether it's running fine. So can you tell me what's the next thing that's happening after DevOps? Can you take a shot? Can you take a guess? You're coming from 2 separate roles of a developer and a sysadmin. You combine them into DevOps. Can you tell me what's happening next? Which was already started to happen, but it will definitely become the norm in the future with the cloud and automation of all these things. So Shar says system architecture. Well, system architecture, of course, system architecture is a broad term. Even in Web 1.0, you had system architecture. It's just how system is built. Now it's more, more complex, but there's still system architecture. Okay, Dharya says cloud automation engineer. Okay, so basically we are heading in a direction where you have, there will not be any more sysadmins, or maybe there will be, no, it's just, just in a sense of humor, I'm saying that maybe there will be just 5,000 sysadmins across the world who will be managing, major organizations and clouds, or let's say 50,000. And everybody else will be either a DevOps or a NoOps. So basically no operations. In fact, so right now I said that you brought together the developer and the sysadmin where he has to handle both things. But in future, the developer will just develop the code, test it on his own machine, and then he'll push it, the code to a GitHub repository. We'll talk about what's a GitHub repository. Some of you might know about what a VCS is, version control system. Some of you might not be aware of it, but we'll introduce it because we're going to use it. All the code that I'm going to develop during the duration of this course, you will find it on GitHub. Right? So we will discuss what that is. So from the perspective of a developer, all that he does is he develops his code and then he pushes it on to GitHub, let's say. And everything after that is automated. Everything after that is automated. It is built, compiled, it is tested. So many different types of tests are run. If there's any problem, he's informed. If there's no problem, that piece of code is taken and deployed into the production environment, and there it is managed automatically by the cloud provider, right? So there is no sysadmin anywhere in the picture. And that is the future, where the infrastructure is being managed totally by AI and ML and the machines themselves. So only the creative part, the creative part is left for humans. Everything else will be self-managed by the computers. So Tushar says that's CICD, right? So yes, that is DevOps, NoOps is exactly what you mean when you say CICD. So CI is continuous integration. Okay, continuous integration, and CD is continuous deployment. So basically you shipped your MVP, and then every Friday you ship a new feature. So you are continuously integrating new features into your MVP, and you are continuously deploying your your code into the production environment. So you are continuously integrating new features and you're continuously deploying, right? So you cannot do it without DevOps and NoOps. So basically it is happening, and the more we are going towards the automation of the infrastructure, the more we are heading towards no operations. So there will come a time when sysadmin job will be a very highly paid job somewhere in the future, but there will be very few, very less demand, because there will be very few vacancies for sysadmins. I remember a time in my own career, where sysadmins were in huge demand, and they were Cisco certified sysadmin examinations, huge demand. Now nobody is even asking about becoming a sysadmin. Okay, so this is to put the entire thing into perspective, which you already answered. The challenges, why software, the challenges. So the challenges that were being faced by the earlier generation will not be faced by your generation. Right? So things are becoming actually simpler. As I said, in a few years' time, I think that you won't even need to do a full-fledged engineering course to become a software developer. It's going to become so simple. Even in schools, people will start building apps, right? So it's becoming so easy. So can you tell me what is going to be Web 4.0? Any idea? Because you are in an advanced Java course, so you need to see where things are heading. You need to have the right perspective. So 2010 has already ended. Now we are in 2020. Web 4.0 is already here. Can you tell me what that is? I've already told about cloud, XaaS, everything as a service, DevOps, NoOps, CICD. What's next? What's the next thing that you see around your world as far as web is concerned? I'll give you a hint. Yes, so I've got one answer. I'll give you a hint. Some of you might be using it already. ML, okay, Rahul says ML, Rahul says robotics, Rahul says AI. So I've given an example here, Alexa, AI and ML, so artificial intelligence and machine learning. So basically this is the ubiquitousness of internet, which can also be called Internet of Things. AI ML I will not write here, because AI ML belongs to all these generations starting from Web 3.0, but from Web 4.0 AI ML is absolute must. So if you are a software engineer, or if you're a software developer in 2022, you have to be aware of the basics of AI ML, because what AI ML means in short is humans will not write software anymore. Software itself will write software now. That's the major step that we are taking forward. So what will humans do? So humans are writing the software that will write itself in the future, right? So humans are now reached a point where we are able to write software that will write itself. So DevOps, NoOps, and there will be no developer in the future, right? So software will be writing itself. And even now you have Alexa and stuff like that, which is learning, right? So if you have Alexa at your home and you live with it for 6 months, you'll realize that it knows more about you than your own mother, right? So that's what, that's what is happening. So if you are a developer in 2020, these are the things that you should keep in mind. IoT, artificial intelligence, machine learning. So focus on that. Now, so basically with this initial introductory session, we have, pretty much understood where the software industry is coming from and where it's going. What are the challenges, why we build software, why data is so important, what are the, architectural level decisions that we take, why to go for SQL, why not to go for, or why to go for MongoDB or NoSQL, what is cloud, what is SaaS, PaaS, what is DevOps, what is NoOps. See, these are just jargon, but it has a continuity since the beginning of the software industry till now and in the future. So I hope that you are pretty clear about what the software industry looks like today and what will look like in the future, and you can imagine your place in it, right?